A very good morning to all of you. I'm Ritu Arora, a faculty from BITS Pilani, and the work that I'm going to present today is titled Learning to Write Programs with Others. This work is carried out under the able guidance of Dr. Sanjay Goyal from JIIT Noida. This paper was selected in the Conference on Software Engineering Education and Training held in China in 2012.
Most of the software development is carried out by teams of software engineers working collaboratively to achieve the desired goal. Collaboration is at the heart of software development. Also, it is must that each member of the team is properly trained to effectively collaborate with others. Our education system at present focuses on developing a student's ability to write programs that are meaningful enough to be comprehended by others. Also, it focuses on developing students' ability in understanding programs written by others. We emphasize here that the software engineering education should also focus on developing students' ability to be able to write programs with others. After all, today's students would be tomorrow's software developers. One such concept that promotes collaborative engagements among students is pair programming. The traditional form of pair programming is based on the driver-navigator model, wherein one person sits in hold of the system and the other continuously and actively observes the work of the driver. There are many instances of applying the pair programming model in classrooms. However, a major drawback of this model is that the dominant student turns down the performance of the weaker one. A variant of this pair programming model has been proposed by Goyal and Kathuria in their paper titled A Novel Approach for Collaborative Pair Programming. Collaborative pair programming facilitates equal participation of each member. The collaborative pair programming model is a two-staged fixed partner pair programming model. The students in a pair first work independently and then work on a combined task that brings together their individual tasks. This model has been successfully tested in a real classroom setup. The students were given assignments based on the model. Collaborative pair programming model is based on four-dimensional taxonomy of pedagogical engagements proposed by Goyal in his doctoral thesis. A drawback of the collaborative pair programming approach is that it does not combine all the levels of the collaborative engagements dimension of the proposed taxonomy. Let's have a look at the various levels of collaborative engagement dimension of the proposed taxonomy. At level 1, which is the lowest level of collaboration, simple exchange of information amongst students exists. At level 2, peer review process happens. Level 3 involves parallel collaboration wherein individual work is integrated to form the combined task. Level 4 involves sequential collaboration. This level engages students in building upon each other's work. Level 5 is the highest level of collaboration, promoting students to work together with each other in a synergistic manner. The collaborative quadruple programming approach extends the collaborative pair programming approach and combines all levels of the collaborative engagements dimension. Collaborative quadruple programming is a three-staged, semi-fixed partner programming model. Let's have a look at the task division model of the collaborative quadruple programming approach. Students are divided into groups of 4. At level 1, each student is assigned individual tasks. At level 2, two students are grouped together to form a pair and carry out the combined task. Similarly, the other two students are grouped to carry out the other combined task. These combined tasks are designed in such a way that it requires students to review, integrate their individual work. At level 3, all 4 students are grouped to work on the larger combined task. This larger combined task requires students to review, integrate, build upon each other's work, and apply the understanding developed through subtasks to achieve the desired goal. It is a semi-fixed partner programming model because the individual student or pair of student that completes its assigned subtask at a particular level is combined with another student or a pair of student who has also completed the assigned subtask at that level. Hence, the pairs are formed in a dynamic manner, encouraging collaboration with more than one peer. The model is proposed to be applied in a real classroom setup. The assignments are designed to motivate students to climb up the collaboration ladder, which is based on the collaborative engagements dimension. The table shows one such programming assignment that involves parallel collaboration. Students first work on the solo task, then on the pair task, which involves review and integration of subtasks, and finally on the quadruple task, which also involves integration of the subtasks. Examples of more such assignments can be found in the paper. The assignments are designed for 14-week semester so that the students are engaged in carrying out dialogue and peer review assignments for the first 2 weeks. In the next 2 weeks, the students work on assignments involving parallel collaboration. This is followed by 2 weeks of sequential collaboration involving review, reuse, adaptation, modification, and integration of subtasks. 8 weeks of assignment involving synergistic collaboration promotes students to work on the highest level of combined task using understanding of the individual subtasks. assignments are also designed accordingly. Hence, collaborative quadruple programming model aims to promote among students the learning to write programs with others. One very good feature of the model is that it promotes interaction and collaboration with several peers. However, it has to be applied with properly designed assignments which are actually designed to promote collaboration and are not mere subtask collections. The following is a list of references.